This is Mr. Gillum, and today we're looking at an example from your Practice and Problem Solving book on page 101. The example says that a scientist used 4 and 317 thousandths liters of a chemical for one experiment. She uses 1 and 75 hundredths times that amount for another experiment. How much of the chemical does the scientist use for the second experiment? When I read this, it very clearly says that she uses 1 and 75 hundredths times as much. So I need to know what 4 and 317 thousandths is multiplied by 1 and 75 hundredths. So this is what I'm thinking. That's what I'm going to try to do. And so what I'm going to do also is I'm going to use different colors for each column that I'm adding up. And I'm going to try to get an accurate answer here. Before I do my calculations though, let's think about our estimation skills. I know that 4 and 317 thousandths is around 4, and I know 1 and 75 hundredths is around 2. I know 4 times 2 is 8. So I'm thinking that my answer should be somewhere around 8. Especially when I'm moving the decimal place, I need to think about whether I've moved it the appropriate number of spots to make sure that the number is close to 8. And then that's basically what is explained here. Okay, that's my estimate there. So let's go ahead and try to figure this out, and we're going to use the decimal or the multiplication algorithm for this problem. So I'm going to start with the very end number. And so when I start adding, I'm going to start at the very end here as well. 5 times 7 is 35. 5 times 1 is 5, plus 3 is 8. 5 times 3 is 15. 5 times 4 is 20, plus 1 is 21. Now, that is for the last digit. The second to last digit, 7, is going to start at the second to last spot when I'm writing my numbers down. 7 times 7 is 49. I'm going to put red numbers up now. 7 times 1 is 7, plus 4 is 11. 7 times 3 is 21, plus 1 is 22. 7 times 4 is 28, plus 2 is 30. It's very important that because we're the second number in, we start in the second spot. And I clearly and vertically align those numbers so that they have the correct place values. I like when I multiply by 1 because I can mental math this one pretty quickly. Notice how the 1 is the 1, 2, third spot in. So we have spot, spot, and then the third spot right there. It's important that you get that in the right spot when we're adding our partial sums together so that you're adding the correct numbers and the correct place values at the same time. So 1 times 7 is 7. 1, 3, and 4. And I did that really quickly, but 1 times anything is the same number, so it should be a quick calculation there. And now I can add these all together. These are all the partial sums. So when we did the little area deal with okay, we had this much, and then, these were double shaded, and we added this together with this, and we found our answer. That's what these numbers are. Okay, these are the partial sums of the area model. Okay. So when I add these all together, I might need to put some place values in there. 5 plus 0 is 5. 8 plus 9 is 17. Carry the 1. 1 plus 5 is 6, plus 1 is 7, plus 7 is 14. 1 plus 1 plus 2 plus 1 is 5. 2 plus 3 is 5. And 4 plus 3 is 7. So obviously, the scientist does not need 755,475 liters of chemicals for their experiment. They need around 8 liters of chemicals for their experiment. So just based on my estimate, I think the decimal is going to go here because I know 7.5 something 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 is close to 8. But there's an exact way to figure that out as well. I'm going to count the number of decimal places that are behind. There are 3 numbers behind this decimal. Okay, and there are 2 numbers behind this decimal. Altogether, there are 5 numbers behind the decimal. And so I'm going to move my decimal 5 places from the end. 1, 2, 3, 4, 5. That's where my decimal is going to go. 1, 2, 3, 4, 5 places to the left. And so, yes, 7 and 55,475. So your 100 thousandths would be the correct answer. It's a big mouthful there, but you can see that our answer does agree with the example in the book. So hopefully that the algorithm makes sense to you. The only difference between whole numbers and decimals is you need to move the decimal to the appropriate position after your algorithm and your sum of your partial areas there. So a couple things that students forget to do. If you're starting at the end, start at the end. If you're starting 2 in, start 2 in. If you're starting 3 in, start 3 in. Okay, and then add these extra place values when necessary. All right, so that's it for today.